Vegetable oils and waxes, extraction and classification. Vegetable oils and waxes are part of the natural accumulation of material inside of plants and plant tissues. We have a lot of different uses for them. In order to do anything, we have to be able to extract them. There are three general kinds of extraction. One is pressing. Pressing is where you put force on the molecule. You crush the cellular material, and it squeezes the oil out. We have a solvent type extraction. In the solvent type extraction, you take the material, you chop it up, you crush it, then you add a solvent that will extract the oil. Then you can remove the solvent and the dissolved oil in it. You heat up the material, this drives off the solvent, you get your solvent back. We can have a hot extraction. This is where you use steam or hot oil or something like that to try and extract the material. You have a way of capturing the oil. I've got several videos of different kinds of extraction processes on another tab, and you need to look at those because they become quite interesting. Let's look at this. Extractions of oils, pressing. You're basically using mechanical force to press the oil out. When we do pressing, you could have a cold press, which is done at room temperature. They monitor the temperature of the material to make sure that it doesn't heat up. It gives you a better quality oil. It gives you less of it. You may be getting a couple of percentage points less oil than you would if you did it in a different way. There is a hot press, which is where the material is heated up before it's pressed. If the oil content is low, if there are other reasons, you have to do a hot press. When you do a hot press, it brings a lot of other dissolved materials into the oil, which could be problematic. One of the most common current ways we do things are what you call the screw press. A screw press generates heat. It's a continuous feed. As it feeds, the material is placed on a screw, which gets into a smaller and smaller area. As it does that, it forces the material to release its oil. You get a lot more material through it. You can do it a whole lot quicker. If you watch one of the videos on olive oil, they have got an old-fashioned press where they put the material and then they squeeze it out with mechanical pressure. Nowadays, if you're not making something artisanal or something like olive oil, you're most likely going to be using a screw press. There is a material called cake. Cake is it's left over after you press out the oil. It's an important byproduct. They often use cake for animal feed. Here is a extra virgin olive oil. This is a cold press. They monitor the temperature. They don't let the temperature rise. If the temperature rises, it's not going to be very good olive oil. And you can see up on the top right-hand corner of the label, it says all natural cold pressed. That's imported from Italy. This is an expeller press, which means this came out of a screw press. This would be a little bit hotter temperature in there. Sometimes they take sesame seed and they actually toast it first to be able to get more oil. This is a expeller press. We have the extraction with solvent. One of the principal solvents used is hexane. Hexane is very easy to drive off. You can do it at a temperature of 63 to 65 degrees Celsius, which isn't too hot. You take the material, you crush it up, you heat it, you agitate it with the solvent. The solvent's going to extract the material. Then you take the material that's extracted, you boil off the hexane, you're left with the oil. It gives you a better yield by a couple of percentage points. You can get the hexane back and you can reuse the hexane. You're going to reuse it. We also have extraction of oils through hot extraction. This is a steam distillation sort of thing. I saw them doing this with mint oil. They would take the mint, they would put steam through it. The steam would volatilize the oil. Then they could get it to condense down. They got a very pure oil out of it. There are also some other terms we use. Refining removes unbound fatty acids. What we would be looking for is fatty acids that are bound onto glycerol in the form of a triglyceride. Refining is going to take out those bound fatty acids. Here we've got the sesame oil. Down at the bottom it says it's refined. One of the things they do with sesame oil is they have to refine it. We have degumming. Degumming is where the material is mixed with water. Notice it says 32 to 49 degrees Celsius. Body temperature is 37 degrees Celsius. This will cause water-soluble proteins in the form of lecithin to be removed. Lecithin is an important byproduct of soybean manufacturing. It's often sold in health food stores. It's a very unique protein in its own right. When we're looking at this, degumming, virtually all soybean oil is degummed These are materials that would accumulate if we left them there. You tried to fry something in here, since the temperature is going to be somewhere above 32 degrees, we'll have moisture in there. You're going to get the gum formation on the outside. We have bleaching. Bleaching removes pigments. They don't do this with bleach. They do it with certain absorptive materials that will take out the carotenoids or other sorts of pigments that are in there. This is done with palm kernel oil because palm kernel oil is very orange in the beginning. They use fuller's earth, which is a type of clay. Same type of clay they use in kitty litter, and it's an absorptive material. It's going to pull stuff out. They can use diatomaceous earth as well. That will absorb the carotenoids and the coloration. You can deodorize. Deodorize, you heat it with steam under vacuum. That will take away volatile organic compounds that would give off flavors or off smells to the material. This is coconut cooking oil. It's unflavored. And this comes out of coconut, so coconut is white on the inside. It's unflavored, it's odorless, which basically means they have deodorized it. We've got winterized. Chill it down to 7 degrees Celsius. That's going to solidify the saturated hydrocarbons that are in there, and it can be filtered out. Rice bran oil apparently is one of the ones that they winterize quite a bit. And we've got hydrogenation. Hydrogenation is a process by which the oil is run over a catalyst. In this case, it's nickel. Nickel breaks the double bonds in the fatty acid. It allows for the fatty acid to now become solid at room temperature. One of the challenges they have is trans fat. When you look at the formation of organic compounds, they can either be in a cis form or a trans form. The trans form does not normally occur in nature. When the catalyst breakdown occurs, sometimes you get the formation of trans fat. They figured out a way to be able to decrease the amount of trans fat that you've got. Trans fat is not healthy for you because you don't have an enzyme to break that particular part of the bond down. Hydrogenation. Put the hydrogen back into the fatty acid, which is going to make it more solid at room temperature. We will have what we would call a fat. Here's your Crisco baking sticks. Crisco is one of the first products that were done with a hydrogenation process. It gives you a solid material at room temperature. A lot of margarine is made with hydrogenated vegetable oil. The newer materials, which are soft spreads, have much less vegetable oil in it. They aren't that good for baking or frying, which Crisco would. They don't have trans fat in them.